Hello and welcome all of you to is electrical. As you all know that we are running this electrical measurement part and we are into our second lecture. Now this second lecture what I will deal is the basic classifications of the electrical instruments. Now the first and foremost classification that we all know, that is the absolute and the secondary instrument. Now to give you a small idea about what we do, that is we are basically running a online only SSCJ preparation course. Okay, and you can call on this number 833-506-7725 for further details regarding the course. In the course what we will be getting, there will be concept based classes for the technical, for the non-technical as well. Every day there will be practice sets that will be given. Every month end we will be giving you a test series, and one of our premier features is that whenever you do a class there will be a recording and that recording will be shared with you, and the notes will be readily available and exam specific notes will be given. Now coming to our today's topic, that is absolute and secondary instruments and their classifications. Basically we classify instruments into basically two types. One is a absolute instrument, another is a secondary instrument. Now what is an absolute instrument? Absolute instruments are those instruments which are used in the laboratory and they are also called as the standard instruments. And what are the secondary instruments? Secondary instruments are those instruments which are calibrated based upon the absolute instrument. That means the basic measurement fundamentals is associated with the absolute instruments, and after calibration from the or with respect to the absolute instrument we derive the secondary instrument. So to write a few points, that is it is available at standard laboratories, standard labs. These are the basic instruments which measure the quantity under measurement, which measure the quantity under measurement in terms of physical quantity, or physical representation. Now what does that mean? It means that there will be a physical representation or physical displacement of any part that will ultimately indicate the value. Suppose for example, if we give an example of the tangent galvanometer. Tangent galvanometer is an example of your absolute instrument. Now this tangent galvanometer, what it does, it basically deflects a pointer from its initial position. Suppose a pointer is having placed in this scale and here it is the 0 position, suppose say. Now after that, after a certain current flow, it will reach certain position, suppose in this position. So there is a deflection. So based on this deflection we are measuring the current. So in this type of instrument, what we are observing here is we cannot get the actual value. Okay, we are basically getting a deflection, and with respect to the deflection we are measuring the current or the voltage, whatever it may be. One more example is Rayleigh current balance meter. Rayleigh current balance is another example of our absolute instrument. So a basic physical measurement is done by the deflection of the pointers. Okay, deflection of the pointers. Okay, now in case of secondary instrument, it is basically calibrated. It is a calibrated instrument. Now what does the term calibration means? Calibration means comparison. Comparison with what? Comparison with respect to an absolute instrument. Comparison with respect to an absolute instrument. Now these instruments are basically found in where? In panels, panel meters, Panel meters are examples of this. Then you are having your labs. In labs, basically our engineering colleges labs, and in other places in labs we are basically using it. Then in plants, in any plant, wherever you are seeing any meter, these meters are basically part of the secondary instrument. Now one more important point is that here we get the results. Here we get the result in terms of actual value. That means based on an absolute instrument we are calibrating the secondary instrument, and that secondary instrument will have a reading, suppose 1 2 3 4 5, like that. If this is a ammeter scale, suppose the meter is, the indicating pointer is sitting at 1, that means the current is measured by the ammeter is 1 ampere. Suppose it is showing 5, so it is actually showing the 5 ampere current is flowing through the instrument. But in the case of an absolute instrument, we do not find that. In the case of absolute instrument, we find basically the deflection of the pointer. So basic ammeters, voltmeter, wattmeters, all are the examples. So for example, we can write ammeter, voltmeter, wattmeter, like that. So these all are the instruments where in that case we see the deflection of the pointer, and the deflection will directly show the quantity under measurement. Suppose a ammeter will show directly 5 ampere as measurement, a voltmeter will show 240 volts as direct measurement, wattmeter will show suppose 10 kilowatts as direct measurement, like that only. Now coming to the next, that is I have shown here some of the examples of the absolute instrument. So this is, you can see, a tangent galvanometer. Okay, here different parts are there. You can see here the circular coil portion, the upper part. There is the pointer portion. There is a complex box is also there inside. Terminals are also there. Leveling screws are also there. This is the basic diagram, the tangent galvanometer, and the number of turns are here. This is a basic simple circuit of tangent galvanometer. Just a simple in the same manner as we connect an ammeter with a instrument or with any circuit, tangent galvanometer is simply in that same simple way we are connecting it. Okay, so this is the basic understanding of the absolute instrument, or here in this case we have shown the tangent galvanometer. Now coming to the next part, that is the secondary instrument. A typical example of secondary instrument, the panel instruments. Here we have shown the panel type instruments. Here you can see this is an ammeter, this is a voltmeter, and this is a kilowatt meter. A wattmeter I have also shown. Here you can see the reading or the scales are there. Okay, in the previous slides you can see one thing, that there is no such marking as the current or anything is marked, but here you can observe that current values are already marked. Current value, voltage value, these are already marked in this case. Now coming to the next topic, that is the classification based on representation. We basically classify every instrument based on whatever it measures, okay, based on the representation. Now based on the representation, we classify instrument into three types. One is indicating instrument, one is recording instrument, another is a integrating instrument. Indicating instruments are those instruments which measure the quantity under measurement by showing or indicating its instantaneous value. Okay, so measuring the quantity under measurement instantaneously through deflection of the pointer or indication or indication it shows the magnitude of the quantity under measurement quantity under measurement. Now record, for example, indicating instruments, we can say the ammeters, the voltmeters, the wattmeters, the energy voltmeter, wattmeters. These three are the basically indicating instruments. Why we where we directly get the indications of whatever the readings are there. Now one type of instrument is a recording instrument. A common recording instrument and simple example is a seismograph. Seismograph is an instrument which measures the earthquake. Wherever the earthquakes are happening, it is measuring. So with the help of a pointer or a stylus, with the help of a pointer or a stylus, stylus, with the help of a pointer or a stylus, it records the continuous oscillations, the continuous oscillations or changes during a measurement. Now recording instruments, we have said seismograph. Seismograph is an example of a recording instrument. And an indicating instrument, the most common type of indicating instrument we all know, that is the energy meter. In all our homes, the meters that use to calculate whatever the power we are consuming, that meter is energy meter, and the integrating instrument is an energy meter example of an integrating instrument. Here basically what happens is we are combining the features of both the indicating instrument as well as the recording instrument. So combination of the features of both the indicating and the recording instrument. Here what is happening here is there is a continuous reading of any instrument. Suppose your energy meter, it is taking care of the rotations of the whatever the coils are there, whatever the discs are there, the discs rotations they are counting, as well as the time is also they are taking care. That means suppose in your home there is a 1 kilowatt of the demand. Now this 1 kilowatt of the demand, how much amount of time you are also utilizing it, that much portion of also it is getting calculated. So it is basically calculating the energy, for example, power into time. So it is taking care of the demand as well as the taking care of the time as well. So time aspect is also included. For the integrating type instrument. Now another example of another type of instrument that we see, basically null type instrument, that is galvanometer is an example of the null type instrument. Here we basically see the deflection only. Suppose there is a centrally mounted zero position where galvanometer pointers can move in this direction as well and in this direction as well. It only shows whether certain amount of balance is there or not. In certain circuits we require balance, that means no current is flowing. In that case what we need a balancer or a zero indicator. So null type instrument is basically that type of an example. Now the classifications that we are already studying, that is classification based on indicating instruments. Some of the examples you can see. So here a simple figure is shown. Here you can see the pointer. This is the pointer part. Here you have seen a graduating dial, as a dial is also shown. Here is the moving system, and this moving system allows the pointer to move. And here you can see a spring is also there, through which the current is also passed. So a common example of an indicating type instrument is a voltmeter. Here you can see a common example of a voltmeter. Ammeter, wattmeter are also examples of indicating type instrument. Now to give you some idea about the recording instruments, so here in the older days, these type of meters are generally used. Here you can see the instantaneous values or fluctuations are continuously recorded in these instruments. So a common example is a seismograph. Here you can see there's a pen is there, the pendulum is there, and there's a paper chart is there. Whenever there is a deflection, it is recording or it is sketching whatever the variations are there. Okay, so this much for the recording type instrument, and an example is seismograph. Now coming to our next part, that is an integrating type instrument. We have seen as common example of integrating type instrument, that is our energy meter. Now see, this is an energy meter. So I am saying some about the disk. This is the disk. The disk you can see. Nowadays we generally don't see this because this is an analog instrument, and in your home you will observe that there is digital instruments are already installed, so you do not see these things. But earlier it used to have this disk, and this disk used to rotate, and you can see the dial arrangement is there, like 0.1, 1, 10, like that it is arranged. So one rotation will give suppose one rotation, one complete rotation will give this one indication. Now if it completes suppose 10 divisions, then this box will get filled with 1. So I'll be coming out in this. So this is the dial arrangement. You can see, suppose this clock rotates a complete cycle. When this clock rotates a complete cycle, here 1 will be indicated. Now when this clock rotates one complete cycle, then what will happen is here 1 will be indicated. Now when this clock rotates a complete cycle, then what will happen is here 1 will be indicated. Like that you can see that actually here it must be 10 to the power 4. 10 to the power 4 must be there, or 10 to the power 3 must be there. Okay, 1000 must be there. Now one rotation, complete rotation will give one reading here also. That means the pointer shifts to this position. Here they shifted to this position. So you can observe whatever. Now you can see the gear and train arrangement, how the gear and train arrangement, and how the meter readings are shown. As I have already said that first this 1/10 portion, will indicate the first reading. Suppose one revolution is completed, so it is showing 1. Now 10 revolutions is completed, then this section will show 1. Sorry, not this section. So this section will show 1. Okay, this section will show 1. So this is, you can see, this is this section will show 1. This is 100th division is shown. Sorry, this is 100th division is shown. This is 1/10th division. So first is this one, 100. Okay, so just let me correct you one simple thing, that is here what it is shown is only this part is shown. Okay, not this part is shown here. Suppose there are 10 rotations, so 10 rotations will give one reading, and this one reading will be reflected in this part only. Okay, the 10 readings will reflect in this part only. After 10 it will jump to there, 1 1 0 0. After that it will be turned here, then there, like that it will go on. So here you can see the dialing arrangement. So a simple understanding will give you that fact that suppose this is meter 1, dial 1. When dial 1 gives us 10 readings, then suppose this is dial 2. Dial 2 will show 1 reading. Okay. Now if dial 2 shows 10 readings, then dial 3, suppose this is the dial 3, then dial 3 will show the 1 reading. Now if dial 3 shows 10 revolutions, it is completing, one complete revolution it has completed, then the dial 4, this is the dial 4 part, the dial 4 will show reading 1. So like that you can understand whatever the arrangement, and here you can see the dial as well. This thing also be taken care in our energy meter part as well. Now coming to the classification based on the quantity to be measured, we all know that ammeter is basically used for measurement of the current. Now voltmeter, we basically use it for the measurement of voltage. Now for wattmeter, we know we used to measure wattage of any circuit through wattmeter. Now in the case of energy meter, we are basically measuring the energy of the system, that is watt into time, that is power into time. Power factor meters are also there, where we can measure the power factor. Other than that we can also have some other meters like frequency meters are also there, Q factor meters are also there. So these are certain quantities that we can measure based on the quantity to be measured. Now we all know that every measurement or every instrument basically operates on certain principles. So these certain principles are basically some of the examples I am showing. One is an electromagnetic effect, another is a heating effect, another is a chemical effect. So these are some of the names. Now electromagnetic induction, then electrostatic effect, then thermo EMF effect. These are some of the examples what I have shown. These 6 types of principle of operation is there. So electromagnetic effect, we are basically using the moving iron or moving coil type or watt hour meter type instruments. In heating effect, we are basically using our that hot wire type instruments where heating effect is basically used. In chemical effect, we can see that the DC ampere hour meters are there. So this okay. So DC ampere hour meters are also there. That is not mentioned here. It will be coming up. Now you can see DC ampere hour meters are also there. Now electromagnetic induction type instruments are basically induction type instruments are examples. Now electrostatic effect is basically seen in electrostatic voltmeters, and thermo EMFs are basically shown in thermocouple instruments. So I will be dealing with all the instruments, and here we will be giving all the ideas about how they are working. Here I have just mentioned the whatever the effects are associated with these meters. For example, for moving coil type instrument or moving iron type instrument, we are using electromagnetic effect. Hot wire type instrument, it is heating effect. Now DC ampere hour meter, then in that case we are using chemical effect. Now induction instrument, we are using electromagnetic induction, you all know. Then electrostatic effect, we are basically using electrostatic voltmeters, and thermo effect, then basically thermocouple instrument. Basically induction type instruments, we all know that induction type watt meters that's there, energy meters are there. MI type, you will be having all, that is MC and MI type will be having watt meters as well as voltmeter as well as ammeters as are the common examples of it. This ampere hour meters are basically energy meters, are basic examples of energy meters. As you have seen, electrostatic effect is shown here is voltmeters. So a common examples of this is that electrostatic effect in voltmeters are basically used where high voltage is to be measured. So high voltage measurement is the criteria on which we are basically using this electrostatic voltmeters. Okay, there are also some thermocouples instruments are there where the temperature difference is getting measured. Okay, so these are the basic classifications. Now if I just want to assimilate everything, so based on quantity we had classified as ammeter, voltmeter, wattmeter, energy meter, power factor meter. You can have frequency meter as well. You can have Q meter as well. And then we had classified based on the effects, that is the based on principle. We had 6 principles you have already shown, that is a magnetic effect is also there, then there is electromagnetic induction, then there is hot wire type instruments, then there was our thermocouple instruments are also there. Like that we had 6 different classifications we have seen. And another thing is there, that is our based on the representation. Okay, based on representation, we had done the 4 classifications. That is our one is an indicating instrument, another was our recording instrument, another was our integrating instrument, and another was our null type instrument. So these are the basic classifications, and a broad classification we had also done, that is the analog and the digital instruments are also there. So mechanical, electrical instruments, electronics instruments, mechanical, electrical, electronics. These are some of the classification based on the modern age. What certain instruments that we are using, whatever classification we have done up to now, all are based on the analog instruments. Now similar digital instruments are also there. Some instruments are mechanical oriented, some instruments are electrical, some instruments are electronics. Now the basic classification, that the overall classification we can see, this absolute and secondary instruments is the overall classification of the instrument. So this much for today, and I will be stopping this lecture here. Thank you everyone for listening to the lecture. Just revise the lecture once again, and thank you everyone for joining the class.